So now we are going to talk about acceleration. Acceleration is basically the rate of change of velocity. So average acceleration is defined in terms of velocity as delta v over delta t, which is by definition. So whenever you see these kinds of arrows with a triple sign, that basically means is by definition. So by definition, average acceleration is defined as v final minus v initial divided by delta t. Instantaneous acceleration is an acceleration at any instant, and this is given by delta v over delta t in the limit when delta t becomes very, very small. Average acceleration does not tell us about the variation of v in the interval delta t. The direction of a average is the same as that of the velocity vectors that it belongs to. So note, since velocity is a vector, acceleration is also a vector. Some important facts. Since velocity is a vector, the change in its direction gives an acceleration, even if its magnitude is unchanged. For example, the components of v can change in such a way that the magnitude of v remains constant. Can you think of any examples? Well, here's an example. Magnitude of the velocity may not be changing, but its direction is constantly changing when things move in a circle. When things move in a circle, they are being accelerated. And we will talk about that when we talk about centripetal accelerations and so on and so forth. So continuing from the example from the last problem, now we are required to find the magnitude of the acceleration at t equals 7 seconds. Now how do we do that? We know that the average acceleration is the change in velocity per unit time. So in this case, it will make sense, since the velocity is pretty constantly changing or decreasing. What we can do is find the slope of the graph, and that will give us the acceleration at t equals 7 seconds. So a average equals delta v over delta t, which means velocity at 12 seconds is 0 and velocity at 4 seconds is 20. So take the difference and your answer comes out to be 2.5 meters per second. Note that we are taking the magnitude here. If we were not taking the magnitude here, my answer will come out with a minus 2.5, which basically will mean is that it is now a decreasing acceleration, or in some people want to call it deceleration.